So f prime of x in first derivative, in first principle, is equals to the limit as h approaches 0 of x, f of x plus h minus f at x divided by h. So this equation, namely star, it will always be given to you in the exam, so there is no need for you to memorize it. You're gonna use this formula, and remember, you need to know it by your heart, because in each and every examination for paper 1, they will always tell you to find f prime of x. If they give you the function, it is a must for them to set this type of a question. So you need to master it well and get it right. Mostly it's 5 marks. I don't know if they changed by this 5 marks. So 5 marks is close to maybe 1.8%. So it's good for you to utilize this one. So let's tackle some examples that are involved in first principle. Let's say now you're given a function f prime of x, which is equals to minus 2x squared plus x. And you are told to find f prime of x in the first principle. So what you need to do first, you need to write the formula for the first principle. So you say f prime of x is equals to the limit as h approaches 0 of x plus h minus f at x divided by h. So now you need to find f at x plus h and f of x. So I will advise you to start by determining this. F at x plus h minus f at x. Then later, you're going to substitute this into this equation. So let's compute f at x plus h from this function, which is here. So when we see x, we're going to put x plus h. So now this one will become minus 2 into x plus h all squared. It's all squared there. Plus x plus h. So we're done with f at x plus h. Let's go to minus f at x. So our f at x is this one. So it will be minus 2 x squared plus x. So now let's simplify. Here we see these two terms raised to the power of 2. So we'll have x plus h, x plus h plus x plus h. So now for simplifying, we can say that we can distribute this negative into the brackets. So negative times negative 2x squared is positive 2x squared. And negative 1 times positive x is minus x. So let's simplify the brackets here. Again, we see that we have brackets which are multiplying each other. So we're going to say x times x is x squared. and x times h is xh, and h times x is xh, and h times h is h squared plus x plus h plus 2x squared minus x. So now let's remove brackets. So 2 times negative 2 times x squared is minus 2x squared. So here, let's pause for a minute. Here we see that we have xh and xh. So they're adding each other. So we know that in our mind we will have 2xh. So now we are no longer going to multiply it individually. We are going to say minus 2 times 2xh. It would give us minus 4xh. And minus 2 times this h squared, it will become minus 2 h squared. Then here we don't multiply anything, but we can remove brackets since it's positive. So we'll have x plus h plus 2x squared minus x. So that some terms which are cancelling each other here, which are like terms. So we have this term here, also this one, are cancelling each other. Even this one and this one, they're cancelling each other. Minus 2x squared plus 2x squared is 0. And plus x minus x is 0. So we'll be left with minus 4xh minus 2h squared and plus h, which is here. So now we know that our f at x plus h minus f of x is this one, which is here. So we can write it somewhere. So our f at x plus h is equals to minus 4xh minus 2h squared plus h. So let's erase some stuff here so that we can get some space. So now since, oh, I'm sorry, even this one is, it's not f at x plus h alone, but f at x minus f of x. So it's f at x plus h minus f of x. So now this one is our another equation, but we can substitute it here. So where we see f at x plus h, we're gonna put that expression which is here. So our expression is minus 4xh minus 2h squared plus h divided by h. So now, since the limit is approaching h, the limit, since h is approaching 0, when we substitute 0 here, the whole thing will become undefined. So it will be better for us if we take out a common factor h outside. So you're gonna do that all the time. So now when we take out the common factor h, minus 4xh divided by h is minus 4x. And minus 2h squared divided by h is minus 2h. Then h divided by h, which is here, is plus 1 divided by h. So h and h will cancel each other. So remember something that you need to put in mind. When you didn't substitute, you need to put the limit. So now it's time for us to substitute. So we're going to say, when we substitute h, when we see h here, we're going to substitute 0. So we're going to have 4x minus 2 times 0 plus 1. So this one is minus 4x. Minus 2 times 0 is 0. So we're going to add 1 here. So this one, it is our first derivative for this function in this first principle. You can always confirm this after writing the first derivative in first principle using the power rule. Remember, the power rule says when you have a function y is equals to x to the n, your dy dx or f prime of x will drop n here, n minus 1. So we're going to do this in this expression to confirm. So this time, our n in this expression, in this term, is 2. So already we have 2 here. So we're going to drop 2. Then we subtract 1 from the exponent. So 2 minus 1 is 1. So this time our n is 1. So we're going to say plus 1. Then we'll be left with 1 minus 0. No, it should be 1 minus 1, which is 0. So we're going to have x to the power of 0, which is 1. So negative 2 times positive 2 is minus 4x. And 1 times x to the power of 0 is 1. So we can see that here we have the same answer. So it's confirming that this one is the first derivative. This answer here is the first derivative for this function. Determine the derivative of f of x, which is equals to 2x squared, and x is equals to 1 from a first principle. So here we're going to discuss two methods on how to do this problem. The first approach, you can start by doing the first principle like the way you know it. Then later you're going to substitute 1. The other approach, you're going to substitute 1 in the beginning of a problem. So let's start with the one normal first principle without substituting 1. We'll substitute later. So now, remember, I'll always write this so that you don't forget. You need to remember that f prime of x in first principle is equals to the limit as h approaches 0 of f at x plus h minus f at x divided by h. So you need to determine what is f at x plus h minus f at x. So f at x plus h minus f at x is equals to f at x plus h. It means that where there is x, you're going to put x plus h. This one is our first expression. So we're going to have x plus h all squared minus f at x, which is minus 2x squared. So now we need to simplify the brackets. So we'll have x plus h minus 2x squared. This one, x times x is x squared, and x times h is xh. H times x is xh. H times h is h squared minus 2x squared. So xh plus xh is 2xh. So this one is 2xh. So 2 times x squared is 2x squared. And 2 times xh, 2xh, it is 4xh. And 2 times h squared is 2h squared minus 2x squared. So 2x squared and minus 2x squared will cancel each other. So your f at x plus h is 4xh plus 2h squared. So let's write this somewhere for some space. Is equals to 4xh plus 2h squared. So now we have f at x plus h minus f at x. We can substitute it here. So the limit as h approaches 0 of f at x plus h minus f at x is this one here. We're going to substitute for xh plus 2h squared divided by h. So now, if we substitute h, which is 0, we're going to get undefined as, so we need to take out the common factor h. So we'll have h, 4xh divided by h is 4x, and 2h squared divided by h is 2h, divided by h. So h and h will cancel each other. You remain with the limit as h approaches 0 of 4x plus 2h. So now you are allowed to substitute a 0. So you'll have 4x plus 2 times 0, which is of course 4x. So now our first derivative is equal to 4x. So they told us that we must determine the derivative of f at x, which is equal to 2x squared at x is equal to 1. So now, to answer this question, we need to substitute 1. So f at 2 will be equals to 4 times 2. 4 times 2 is 8. And that is the answer. So another approach that I told you about, you can substitute 2 from the beginning. We still need to determine f at x plus h. But where there is x, we're going to put 1 because it's our x. And let's see if we really get 8. So let's save this here. F prime of 1. Did I write 2 there? It should be 1. So our first derivative is 4x. 4x. So our x is 1. So we're going to put 1 here. Then our gradient is 4. Sorry about that. So now we need to substitute 1 from the beginning. So our f, where there is x, you're going to put 1. So you'll have 1 plus h minus f at 1. So in the equation, where there is x, you're going to put 1 plus h. So you're going to have 1 plus h all squared. And f at 1, when you substitute 1 here, you're going to have 2 times 1 squared. So this one will become 1 plus h times 1 plus h times 2. Of course, 1 squared is 2. So here you're going to have 1 plus 1. 1 times 1 is 1. And h times 1 is h. So now again, we need to say 1 times h, it should be h. Then h times h is h squared minus 2. So this one will become 2, and h plus h is 2h. So we're going to say that's one. This one is 2h into 1 plus 2h plus h squared minus 2. 2 times 1 is 2. And 2 times 2h is 4h. And for 2 times h squared is 2h squared minus 2. 2 minus 2 is a 0. So we'll be left with 4h plus 2h squared. So our f, 1 plus h minus f at 1 is equals to 4h plus 2h squared. So now, where there is x, you need to put 1. So we're going to put 1 here. So now we need to substitute. This one will become the limit as h approaches 0 of f at 1 plus h minus f of x, which is here. So this one will become 4h plus 2h squared divided by h. When you substitute h, we'll have a 0 over 0. So what you need to do is to take out a common factor, h. So h, 4h divided by h is 4. And 2h squared divided by h is 2h divided by h. So you'll be left with 4 plus 2h. And when we substitute, we'll have 4 plus 2 times 0. Of course, our first derivative is 4, which is here. So that's how you deal with the first principle. Hopefully now you will get it. And thank you very much for watching. If you have not yet subscribed to the channel, feel free to subscribe. And if there is something that you don't understand, comment on the comment section below. And thank you very much for watching.